So for 6 through 14, it asks us to apply the properties of logarithms to simplify our expression, trying to do it without a calculator. So some of them we've seen before, others we're going to use these new properties to kind of rearrange it and solve for them. So the first one, we know that anything to the 0 power gives us that 1. So this first expression is just going to be equal to 0. The second expression, number 7, we've got log base 3 of the square root of 27. So what does this equal? So if we rewrite this, the square root of 27 equals 3 to what power? I'm just going to rewrite 27 as 3 cubed. So if we kind of need this in an exponential form, instead of keeping that in radical form, we're going to say, okay, well, this is 3 cubed under the square root, so this becomes 3 to the 3 halves. So what must our whole expression equal? 3 halves. Eight, natural log and e undo each other. And again, if we were to write this out, the natural log would come over. E to what power equals e to the 16? It has to be 16. So again, can write it out, but they're always going to undo or cancel each other because they're inverses of one another. Number 9, same idea. 5 up to the power of log base 5 are going to cancel. But if we rewrote it to undo this exponential piece, we would bring this over and actually make this log base 5 of what? Equals log base 5 of 12. So those logs are the same, so it has to equal the value 12. Number 10, same idea. This is a log base 10. Remember, if you don't see that base, you have to know it's a base 10. They would just cancel out. This exponent with base 10 and that log base 10 cancel out, and you're left with x minus 2. So this whole thing would equal, and you would be left with x minus 2. 11, same idea. This is e, an exponent with base e to the power of a natural log. So if we rewrote it or undid it, we would have natural log and natural log. So they would cancel out, and you would be left with 4x. 12. We do have a log base 8, but what about that 3 hanging out there in the front? Well, if we rewrote this, we would bring that 8 over, so we would have 3 log base 8 of 4 equals 8 to what power? Well, remember, our properties say that if we have a coefficient out in the front of a log expression, that becomes an exponent. So this is really log base 8 of 4 to the 3rd equals, and this should be not 8 to the power of, this should be log base 8. So if that's the case, it needs to equal that expression. So it's going to be 4 cubed, which is 64. 13, same idea. That 4 is going to come to the front. So this is really e to the power of the natural log of 2 to the 4th. That e and that natural log cancel out. I can show you guys, though, again, how it works. Equals what? So we'll bring that over. We'll have the natural log of 2 to the 4th equals natural log of what? So it has to be 2 to the 4th, which is 16. So again, making sure that you know and understand how to go back and forth between an exponential expression and a log expression, whether it be a log base 10 or a natural log or an exponent base e or an exponent base 6. Doesn't matter which form. It's vital that you guys know how to go back and forth between the two. Let's look at 14 and 15 yet. So it's giving us number values to try to practice with our properties here. So if we're given the information that log base c of 2 equals this, log base c of 3 and log base c of 5 equals this, it wants us to find log base c of 5/12. So what we're going to do is say, okay, using 2, 3, and 5, how do we get 5/12? Well, it would have to be log base c of the 5 over, how did we get 12? 2 times, I had to think about that for a second. 2 times 2 times 3. So 2 times 2 is 4. 4 times 3 is 12. So based off of our properties, what we have here is 3 things being multiplied together in the denominator and 1 thing on the numerator. So we know, and actually I'm going to put this up here, that anything on the top is positive. So we've got a positive log base c of 5. So I'm going to kind of write it out as log base c of 5. And then everything on the bottom is negative. So all of these on the bottom, so our first log base c of 2 minus the second log base c of 2, and then minus that log base c of 3. So that would be like the expanded form of that, and we're given those decimal values. Log base c of 5, it's telling us equals 1.000. And then our log base 2 is 0.431, so minus 0.431 minus 0.431, and then plus 0.638, which is that, no, not plus, minus that 0.683, which is our log base c of 3. So once you add and subtract those all together, we get a value of negative 0.545. So it's kind of weird that it gives us number values, but it's good practice to continue using those properties. So why don't you guys try 15?